try one more, okay? F. Let's suppose it was, oh, I don't know. Instead of 2x, let's make it x squared. And just for the sake of it, just to make it a little bit easier, let's just make it a power of 2, because I'm going to illustrate something with this example in a second, and I actually will want to expand, okay? Let's just try what we've been doing so far, okay? Capital F, right, power goes up, right? So x squared plus 1, 3, yeah? Divide by the new power, now what?
2x.
Well, so far, this is what we've been doing, okay? Derivative of the inside, right? Derivative of the inside, okay? So I get this, cubed on 6x. Okay, now, just for the sake of it, I'm going to expand this out. This is why I picked 3 rather than 100, okay? Because I'm interested in, you know, finishing this before the sun goes down. So let's do the expansion for this, okay? Now, eventually you'll learn how I do this so quickly without actually doing it a couple of steps. Yes, it is. When we do binomial theorem, but this is going to be, let's see, x to the 6 plus 3x to the 4, 3x squared plus 1. Yep, on 6x. Okay. Now, if you like, you can go ahead and you can do x squared plus 1, and then x squared plus 1 squared, and you can go and do it. But you could, or you could just trust me. That's what you're going to end up with. Okay. Let's just do this. Go one more step. So x to the 6 divided by 6x. That's going to be x to the 5 on 6. Right. This is going to become x cubed on 2, x on 2, and just that. Okay, now, when you look at this, right, is there anything suspicious about this? Anything unusual? Does it look like it's a plausible answer? Now, when I look at it, right, with another color, it starts off looking pretty okay, right? Because when you look at this thing, the whole thing ought to be, when I look at this, the whole thing should be a power of 4. So when I anti-differentiate, right, I should end up with power of 5. So that looks like it checks out. And then, you know, this expansion sort of looks okay. Then you get to this guy. Now, why might that be a problem? Why might that set off alarm bells for you?
Because you can't anti-differentiate x to the power. That's not related.
It's not that. Actually, it's not that far.
It's not that unrelated.
Think about this, right? I anti-differentiated, right? And so this is where I ended up. Okay, but where would this come from? Which of these terms, right? Because I can actually expand this out. It's not that hard, right? Which of these, when I anti-differentiate it, turns into this? Now, let's just keep that there for a second. Suppose, right, rather than try and do the shortcut, we actually did expand it out. What would happen? Okay. Sorry, I keep on doing this. My bad. Plus C. You get the idea. Okay. Let's expand this out. It's not a difficult expansion to do. X squared plus 1 all squared. It's going to be what? X to the 4 at the front plus 2x squared plus 1. Okay, now let's anti-differentiate. Right? F prime is
X to the power
up, divide, power up, so x cubed, there's a 2 at the front, divide. That goes up, and then there's my constant. Now you can see, superficially they are similar. You still got the 5, the 3, the x, but then, what happened? Now, which one is right?
It's the answer both of them, and you can rearrange them.
Now, I'm going to suggest that they can't both be right. Okay, here's why. If you remember looking at quadratic identities at the end of last year, or maybe you don't, that's okay. When you've got, you know, x to the 5s and x cubes and that kind of thing, there's going to be a 5th of an x to the 5 here. And there are no other x to the 5s anywhere else here, right? In the same way, there are no other x to the 5s over here. So there's nothing that can, you know, make this 6 turn into a 5, right? These are irreconcilably different. Okay, I can't turn one into the other. And the clincher is really this guy. This guy has no parallel at all over here. Okay, that's an x to the minus 1. Okay, so how can I tell which one is right?
Can we say that one's right?
Can we say this one is right?
Yes, because is there some strange rule that we don't know of that I'm just going out on a limb? Is there a strange rule that means you can't anti-differentiate chain rules when you have a x to the power of something which is not 1 inside brackets?
There's actually some sense in there, I think. Yeah, somewhere being the operative word, okay? Alright, now, which one is right? Now, there's a real way you can tell which one's right or not. Is
Differentiation.
Oh, that one's undefined at x equals 0. I think actual.
That's true. That's true. That's weird though, isn't it? Right? Let's go after that because it's not gonna help us work out the right answer, but it is gonna tell us that there's problems with this one, okay? This function, what does it look like? You could actually make some guesses as to what it looks like, right? After you expand it, you can see it's like this, right? So it's going to be, I don't know, it's something like that. I don't know. It's a quartic of some kind, okay? Now, when you look at it, right, if you're going to the primitive, okay, that means this is the derivative of this function, okay? But the derivative exists everywhere. There's no value of x you can put into it which breaks it, okay? But this doesn't exist everywhere. As Justin said, doesn't exist at x equals 0. I'm going to have some asymptote here, right? So where's the asymptote on this derivative? Like when you have the derivative of something which behaves asymptotically, it should go off to infinity, right? But this is just behaving pretty normally.
Does
okay?
the graph actually look like that?
Be pretty close. I don't know where its intercepts would be because I haven't. I suspect it has no intercepts because that could never equal 0. But
shouldn't it just be like a really, really tall graph? Well, why does it have a wonky triangle?
I'm not sure. We can have a look at it later. But anyway, I'm just guessing. Okay. Now, the way to really know which one is right or not is to differentiate. Okay. So let's give each one a go. Let's take this one that we got first, and let's just.
If you differentiate from this first, a higher step, will it get back to?
Well, it should be all of these steps, 1, 2, 3, 4. If I did my algebra right, shouldn't matter which step I differentiate, because they all should be the same. Okay. So which one should I do, actually? I mean, we can choose any one. These are all the same thing.
Oh, because it's
should I do this one, this one, this one, or this one?
You can't. Is it to do with quotient rule? Why that one's wrong?
Well, this is a quotient. Should I differentiate this, or should I differentiate this? Which one do you think would be easier?
The bottom. Oh.
Why can't we have both?
How do you say that? Is it part of quotient?
I suggest the bottom one probably because I don't like quotient rule. I just don't like quotient rule. I actually haven't tested it out. Maybe it would be quite simple, but I'm going to go with this one because power is really easy to work with. Okay, let's differentiate. Do it with me. X to the 5 on 6. What does it become?
5x to the power.
5x to the power goes down. Power down. Okay. On 6, right? Yeah. Differentiation is so boring compared to. Okay. X cubed, right? 3x cubed on 2. Sorry, 3x squared on 2. Okay. Yes.
Plus half.
That's just a half. What's this guy become?
Plus 6 on.
That's a 6x to the minus 1.
6 on 36.
Right? So minus 1 over 6x to the minus 2. So it's on the bottom. And then the constant disappears. Okay. Now, does this look like I could factorize it and twist it so it would turn into that?
No.
Yeah, the fractions just get worse and worse, right? And
actually,
then like
it's to the power of 4.
this guy, where are you going to put him? Right? Yeah, that's right. Go home, you're drunk. All right, let's try this one instead. Okay, let's differentiate this.
Yes.
Okay, and you can already start to see, right? Next to the 5 going to come out the front and then cancel, like so, right? And the 3 is going to come out the front and cancel, so you're going to get 3 times 2x squared on 3. So that's why, yeah, the 3's cancel. This just becomes 1, constant disappears, and that's looking pretty convincing to me. Okay. So, therefore, what have we concluded? Okay. This line here, specifically this step, is bogus. Okay. So this reverse chain rule, right? You have to be careful. You can't simply divide through, right? See this step here? We divided by the derivative of the inside, okay? You can't just divide through by anything, right? It's a bit like constants, right? We can muck around with those. So the derivative of, for instance, 5x, okay, is the same as 5 times the derivative of x. Does that make sense? Well, that's okay, right? The derivative of 5x is 5. 5 times 1, that's all good, right? So being that we can do that, we can move constants around, we can take them in and out, and we can multiply, we can divide, or we can multiply, that's okay, right? But once x's come into it, other rules seem to take over, okay? So if you see something like this, you still need to expand out, okay? We're gonna deal with guys like this a bit later. There's another sort of part of reverse chain rule that we have to learn, but
is it for any
steps.
power of x inside?
It's for any kind of x. If I'm not just multiplying or dividing through by a constant, I'm in trouble, okay?